Y, think of all the interesting things that are happening. When I press Y, it's calling set state in the subject. Set state remembers that in its global variable and then calls notify observers. Notify observers is going to notify all 4 of those observers that it has new information. Those observers, if they're in a state where they want the information, which ours are because they don't have any other fancy state, they're going to then ask it to get its information. It's going to do that and hand them the information. They're going to use their time zone and do their thing. So every time I press Y, all of that communication happened and all of those observers did their things. Okay. Let's do another one. Okay, so the time changed just a tiny, tiny bit. Okay. But remember, this is all stuff that can be changed at runtime. So in my case, if I type P, we're going to simulate the fact that Paris says, you know what, I'm offline, I'm turned off, I don't want this information anymore. So Paris is going to unregister itself, right? So now in the future, I'm only getting time from the other 3 because Paris is gone. And now when I update, I only will get times in those 3 particular time zones. And then, of course, in the end, I can exit, etc. Okay. So it's a really interesting model, right? Really interesting. You don't see the word Paris observer, Sydney observer, Seattle observer, Tokyo observer. In fact, if we want to make another observer here, we can make it, and what has to be recompiled, right? If I make a, let's see, what other place in the world, Mumbai. I want a Mumbai observer. What has to be recompiled of this whole project? What has to be recompiled? Nothing except it, right? That's the only class that has to be compiled, and that's pretty cool, right? That's pretty cool. Nothing else has to change. The subject didn't even know. The subject code can ship out to customers, and it doesn't even need to know the existence of these things, right? New things can come into being and play in this universe, and the subject doesn't have to care. That's cool. Okay, that code can be untouched. So that's what the observer does, right? That's what the observer can do. All right. Any questions about that? Now I took some code from, I don't know, somewhere on the web, and then made this model myself to try to show you these things. There are some other ones. There's a number conversion, a number-based conversion from Tutorials Point. That's one that I've linked, and I think I probably based mine kind of mostly off of that. The Head First book has some examples that you can download, and that you can just get online. You can just go to their book and download the stuff, right? So they have in the Head First one, they have a weather data station, and that one is a push model where it's going to send the data regardless of whether they need it or not, and then they have to pull the pieces that they need. So that's a fun one to look at if you have time. And then all of that stuff is actually listed on the slides if you want to see it. Okay. The other thing to note is there is some built-in support in Java, but nobody likes it, right? People don't like to use it. And as we just saw, it's not like it's hard to make up this whole thing yourself, right? There's not a lot of moving parts. So it's not like you need a lot of help to do it. Java did decide to do it. We're not going to use it in our project, but here's the problem, right? If you want to do this, you have to make your subject inherit from the observable class. Notice, as soon as you say the word inherit, you've already lost a lot of people, because they're like, why would you make me use my one chip that I have for inheritance? Remember, I can only have one parent. You're making me use the one chip that I have for inheritance for your model. So nobody likes this fact that they made you inherit from a class. It's not an interface, it's a class. So because of that, you'll find that a lot of people will poo-poo it online and say, yeah, no, we don't want to use your thing, right? We're not going to use Java's thing. So there is some support, and if you're not doing any kind of inheritance, you might be able to do it. But again, frankly, it's just not that hard to do yourself. Make the two interfaces, put those basic things in them, and then tweak them as you need them. That's it, right? It's not that hard. It does, but the problem is if they provided an interface, remember, in our cases, both of those interfaces probably need tweaking, right? So they couldn't really provide that and really make an extensible model. So I guess they did something, right? They did their best thing. Yeah, that's what they could do, but it's a little bit underwhelming, right? So that stuff's listed there, and there's a whole bunch of resources listed there as well, right? So that will take us to the end of our talk on Observer. And but that's also not going to leave us a lot of time to talk about project stuff, but it will leave us a few minutes. We can start talking about a couple of the key pieces in terms of the math, and then we'll have to come back next week and pick it up. And that means, yeah, that means designs can't be due. It means we have to cancel the designs or move them to next week. We'll probably just cancel the designs and actually design it together on Tuesday. Which also means that we are probably gonna have to stop and not do project 7. Oh well, we'll figure that out. Okay, I don't want to overload you at the end of the quarter, and this project's going to take some time and effort. So, all right. Any questions first about the observer stuff? I'll post the sample code if you care for that little example. It's not really very fancy, you saw, but I'm glad to post that code if you like it. Yeah, Ben, go ahead.
Just an idea, but so you don't have to jettison the last project. You could make a video